In this video, I'm going to go over finding the domain and range of functions from their graphs. The domain, quick review, is the input, all possible inputs that we could have for a function. And the range is all possible outputs we could have for a function. So let's look at number one first. Notice there's no tack marks or tick marks here because it doesn't matter. There's arrows, meaning it goes on forever. And if you have one going up and one going down, doesn't matter which direction, it's just a general rule that your domain is all real numbers and your range is all real numbers. You just got to make sure that it passes the vertical line test, that it is a function, Now, number two. See, we have an arrow here. Okay, so we know that goes on forever in both directions, right? The horizontal being our input, the vertical being our output, right? The range. So, but do we have an arrow here? No, we have a dot. So that means we start here and we don't go past it. So if we're looking at just the domain, just the horizontal part of it, we don't go past 1, 2, 3, 4, -4. And we include the -4 because it's a closed dot, right? So we got to remember in interval notation, we use a bracket to make sure we include -4. Another way to put that would be like x is greater than or equal to -4. It's the or equal to. That's why we have the bracket there. Just as a quick reminder. Now, if that goes on forever, then the domain must go on forever in the positive direction, right? That's why we put the -4 first, because we have, when we're writing interval notation, we put the lowest number first from the left. All right. All right. For the range, it's going down, right? A downward arrow, sort of. I mean, it doesn't have to be going straight down. It just has to be going slightly down, which means we start with negative infinity because we're going downward, right? And we're including all those negative numbers up until we get to here. Let's say it's +3. Forgive the crude drawings, but you don't have to have correct drawings to do well in math class. I'm living proof of that. 1, 2, 3. All the way up to +3. Oh, does it include the 3? Yes. Got to remember to put the brackets there. See? Not -4. That's the domain number. +3 is the y-axis number for that point. The point is at -4, 3, to be precise. And that's why your domain and range end up like that. All right? Got to watch out for closed dots in graphs. Now, the alternative is an open dot, like we have here in number 3. What does an open dot mean? It means we do not include that point. We include all the numbers up to that point. You know, this is 1, 2, 3, right? So we include 2.999, but we do not include 3. So what do we do in interval notation? Well, we got to start with domain. We got to start on the left, right? And go to the right. So what's on the left? -1, -2, -3. And that's a closed dot. Ugh, all those closed dots. And the domain keeps going until it stops here at +3, and it doesn't include the 3. So it's just a parenthesis instead of a bracket. All right, what about the range? Now, start from the bottom and go up, right? Bottom is -1, 2, 3, 4, -4, and that's the closed dot. All the way up to 1, 2, 3, +3. Okay. And that's it. Nothing else to it. All right, for these next three, I kind of just have some standard functions. I actually wrote out the functions here, right? And it's helpful to understand these because if you see that f of x equals just a number, you know it's a constant, and that the domain is all real numbers because, you know, arrows. And the range is just whatever that number is. It's a constant. It's always at 2 all the way around the world, across the universe. In the textbook, it said to do this for interval notation, but that seems like a bit much. You could just say range is 2, and that's it. But ask your math teacher which way is right for you. Anyway, moving on. This is the identity function. And it's just f of x equals x. It's also a linear function. You might recognize it as mx plus b. It's just m is 1 and b is 0. That's all. That's the only difference. So whenever you have a function that is like mx plus b, you know it's just a line and it goes on forever, right? And if it goes on forever, what's the domain? Negative infinity or positive infinity are all real numbers. And the range, well, this time it's diagonal. So it's going up at all or down at all. Then it's including all those numbers too. Just like up here. See that? You got arrows pointed in both directions, one going up and one going down. You're including all real numbers in both domain and range. It's just a rule, you know? Now, what if we mix it up a little? What if we have a absolute value equation? Well, what happens is we get all these positive numbers, you know, positive input, positive output, you know, all the way until we get to 0. And then we have a negative input and we still get positive output. So, what would our domain be? Well, we're still going, you know, to the left and to the right, both. So the domain is all real numbers. The range, though, both of these arrows are pointed up. Neither of them pointed down. So what is the lowest point they get to? Because we go from the lowest up when we do the range. 0. We include the 0 because we can put a 0 in there and get 0 out. That's fine. And we go to positive infinity. It's really that simple. But it is more to do with the concept of it, especially for these arrows everywhere. I have some more examples later. All right, here's the next few examples. I'm doing all of these because once you get an idea of what the domain and range is of the toolkit functions, then when you're asked for the range of a function, specifically the range of any function, even if you're just given the equation of it or the graph, you should be able to realize, okay, if it's cubed, then it's, you know, it's going to be going up in both directions, so the range is all real numbers. If it's well, I kind of gave that one away, didn't I? So we got arrows there. And same for the domain, right? Oh, see, that was easy. What about a quadratic function? Parabola. See, now if it's negative, you got to remember it kind of flips over the x-axis there, and the range actually can get flipped. But usually it'll just be from the origin, which is the lowest point in the parabola, in this case 0, and it will go to infinity. If it was negative x squared, then it would go down like this, and it will go from negative infinity to 0, right? Just an example. All of these can be flipped like that. Anyway, enough about that. What about the range? Oh, there's a hole there. Range, all real numbers again. Arrows. And with right and left, they seem to be covering everything to the left and to the right. Just not everything downwards. That's why we start at 0 and we go up for the range. All right. Number 9. X in the denominator. So we get this, and x cannot be 0 ever. So what do? Domain. All these negative numbers, skip 0, and then all those positive numbers, right? So we need to include all the negatives up to a point, and then exclude 0, and then include all the positive numbers after that. Got to use the notation union to make sure it's either this or that, but never 0. And make sure those are parentheses. Same thing with the range, right? We're going from the bottom up, skip to 0, and keep going, right? So it includes all these numbers. So it's actually the same as the domain, sort of, just in the vertical direction. What if it's 1 over x squared? Whoa, wait a minute. Okay, domain, still including everything left and right, right? Just not that 0. So negative infinity all the way up to 0. And then from 0 all the way to positive infinity. Wow, okay. What about the range, though? We're not including any of the negative numbers in the range, right? It never gets below the x-axis. So from the bottom up, we start at 0 and we go to positive infinity, and that's it for the range. Square root of x. You can't have a negative number, so you can't have a negative input. That's why the graph is just blank until you get to here. And all of a sudden, boom, 0, you get a point. So what's the domain? 0. Oh, and we include 0 in it, right? So we get bracket 0, positive infinity. And range, same thing. Once you take the square root of that, it's not going to be negative. If you have a negative input in the first place, it would give you an imaginary number, which we can't have. So range is also 0 to positive infinity. The domain is getting, is going towards infinity faster than the range, but they're still going towards positive infinity. Cube root of x. See, the even numbered roots always stop at 0. They can't be negative. But the odd numbered roots, they keep going. So what's your domain? Well, we got arrows in both directions. All real numbers once again. And the range? Arrows, both directions. I mean, it looks like it's going straight to the left, but it's sort of tilted downward. It's just a very, very flat surface, but not quite. Flat slope, I should say. All right, so you just gotta keep those images in your mind whenever you get a square root or a 1 over x. Just remember, don't include that 0 or don't include any negatives at all. That's how you find the domain of a function, isn't it? If you've watched my previous video. Thank you for watching.